Hey guys, so welcome back. Today we'll be talking about types of numbers and classifying numbers. First, we have natural numbers. Now, natural numbers are also known as counting numbers. So we're going to write a note here and we're going to say counting numbers. So natural numbers start with the number 1, it goes down to 2, it goes down to 3, 4, 5, and it goes all the way down. Next, we have whole numbers. Now, whole numbers are very similar to natural numbers, except whole numbers start with the number 0, then goes down to 1, 2, 3, 4, 5, and then it goes all the way down. Now, the important thing to remember about natural numbers and whole numbers is that natural numbers start with the number 1 and whole numbers start with the number 0. An easy way to remember whole numbers is to remember this O here in the word whole. Remember that it starts with a 0. Next, we have integers. Now, integers are whole numbers and negative numbers. So we're going to write our whole numbers here on the side. So we're going to say integers are whole numbers. So these are going to be our whole numbers here, 4, 5, and it goes all the way down, and negative numbers. So I'm going to add my negative numbers here, and then it goes all the way down as well. Next, we have rational numbers. Now, rational number, when you look at the definition of a rational number and look at the word itself, it says rational, so ratio. That means that any numbers that can be written as a fraction or a ratio is a rational number. So we're going to add a note and we're going to say fraction or ratio. And remember, if you are looking at fractions and ratios for rational numbers, always remember that your denominator cannot be 0. Because if your denominator is 0, that means that it's going to be undefined. The third point to point out for rational numbers is that if you have a decimal, we're going to say decimal here for decimals. If you have a terminating decimal or a repeating decimal, that decimal is also a rational number. And for terminating, we mean that the decimal ends or repeats. So let's look at, for an example, 0.5. 0.5 is a rational number because 0.5 can be written as a fraction. 0.5 is equal to 1 over 2. So because 0.5, it ends, it's a terminating decimal, that also indicates that 0.5 is rational. What about 0.25? 0.25 is rational because 0.25 can be written as a fraction, which is 1 over 4. And also because 0.25 is a terminating decimal, it ends. What about 0.125? 0.125 is a rational number because 0.125 can be written as a fraction, which equals 1 over 8. What about the number -9? Is -9 a rational number? Yes, it is, because -9 can be written as a fraction. If I turn -9 into a fraction, it would look like this because we have our imaginary 1. So therefore, -9 is a rational number. What about 0.3 with a line over the 3? This means 0.33333, and it keeps repeating over and over all the way down. So because this is a repeating decimal, then 0.3 with a line over a repeating decimal is also a rational number. So now let's look at irrational. Irrational numbers are the total opposite of rational numbers. So when we're looking at fractions, these are numbers that cannot be written as a fraction or a ratio. So we're going to write a note here. We're going to say cannot write as a fraction or ratio. So when it comes to decimals, if that decimal is not a terminating decimal or a repeating decimal, then that decimal number is irrational. So let's look at, for an example, the square root of 2. Is the square root of 2 irrational? Yes, it is, because the square root of 2 cannot be written as a fraction or a ratio. The same with the square root of 7. The square root of 7 cannot be turned into a fraction or a ratio. Therefore, the square root of 7 is also irrational. What about the square root of 2 over 3? Although this is a fraction form, the square root of 2 is already irrational. So the square root of 2 over 3 makes this entire problem irrational as well. What about pi? Pi is irrational because pi equals 3.14159, and it goes on and on and on without terminating or repeating. Therefore, pi is irrational. Then we have real numbers. Real numbers are positive numbers, they're negative numbers, they're fractions, they're decimals. All numbers are real numbers. Now, we also do have complex numbers and imaginary numbers, but we will not be discussing those in this video. We're just going over a basic review over the common types of numbers that we use. So the cool thing about classifying numbers is that all the numbers are indeed connected. For example, if you are trying to classify a number and you notice that number is a natural number, if it's a natural number, that means it's a whole number. If it's a whole number, it's an integer. If it's an integer, it's rational. And then you have your irrational numbers on the side. And don't forget, all of these numbers are all real numbers. So let's look at some examples. So let's say we had the number 46. Is the number 46 a natural number? It is a natural number. Is the number 46 a whole number? Yes, because if it's a natural number, it is a whole number. Is it an integer? Yes. Is it rational? Yes, it is rational. And of course, it is a real number as well. So the number 46 is natural, whole, integer, rational, and real. What about the number 0? Is the number 0 a natural number? It is not a natural number because remember, natural numbers start with the number 1, 2, 3, 4, 5 and goes on and on and on. Is it a whole number? Yes, it is a whole number because whole numbers start with the number 0. So 0, 1, 2, 3, 4, 5, it goes on. So if it's a whole number, is it an integer? Yes, it is an integer. Is it a rational number? Yes, 0 is a rational number. And is it a real number? Yes, it is. So the number 0 is whole, integer, rational, and real. What about the number 1 over 7? Is the number 1 over 7 a natural number? It is not natural, so I'm going to put X here. Is 1 over 7 a whole number? Nope, it is not a whole number. Is 1 over 7 an integer? It is not an integer. And what about, is 1 over 7 a rational number? Yes, it is a rational number because 1 over 7 is written as a fraction and or a ratio. And is it a real number? Yes, it is. So 1 over 7 is rational and real. So what about 9.325? 9.325, is this number a natural number? It is not natural. Is it a whole number? Nope. It's not a whole number. Is it an integer? It is not an integer. And is it a rational number? Yes, it is a rational number because the number ends. It's a terminating decimal. So that makes 9.325 rational. And is it a real number? Yes, it is a real number. So 9.325 is rational and real. What about 9.325, 6, 8, 9, 10, and it goes on and on and on. So is 9.325689110 a natural number? No, it is not natural. Is it a whole number? Nope, not a whole number. Is it an integer? Not an integer. What about rational? It is not rational because the number continued going on without ending, and it's not a repeating decimal. So since it is not terminating and not repeating, that makes this number here irrational. And since it's irrational, it is also a real number. Okay. What about the square root of 3? Is the square root of 3 a natural number? Nope, it is not a natural number. Is it a whole number? Not a whole number. Integer? No. Is it rational? Not rational. Is it irrational? It is irrational because the square root of 3 cannot be written as a fraction or a ratio. And is the square root of 3 a real number? Yes, it is a real number. So the square root of 3 is irrational and real. So what about pi? Is pi natural number? No. Whole number? Nope. Integer? Nope. Rational number? Nope. Irrational? Yes. And real number? Yes. Okay, what about -5? Is -5 a natural number? It is not a natural number. Is it a whole number? -5 is not a whole number. Is -5 an integer? Yes, it is. So if -5 is an integer, it is also a rational number because -5 can be written as a fraction. Don't forget you have like an imaginary 1 here. And is -5 a real number? Yes, it is. So -5 is integer, rational, and real. All right, let's try one more. Let's try the square root of 25. The square root of 25 is a perfect square, which equals 5. So, is the number 5 a natural number? Yes. Is the number 5 a whole number? Yes. Is 5 an integer? Yes. Is it a rational number? Yes. And is it a real number? Of course, it's a real number. Okay, so the number 5 is natural, whole, integer, rational, and real. And the key takeaway for this is the square root of 25 is a perfect square, which equals 5. All right, so that is all we have for today, and I will see you all in the next video. Bye.